welcome Professor Sanjay, and thanks a lot, sir, on coming you on YourPedia Education, and I'm honored to interact with you today.
It's my pleasure. Thank you.
Okay, Professor Sanjay, I have made some kind of questionnaire, my homework related to the domain of your research, and my first question is related to the personality only. So, sir, I have gone through your profile and I found that you started your journey from IIT Kanpur only as a student, and then you went to University of Minnesota, and then again back to IIT Kanpur as faculty. So, we want to know briefly about this journey from you, sir.
Sure, sure. So I can even start before I went to Kanpur. So I was born in Dehradun, and that's where I did my schooling. And in fact, when I was growing up, I did not even know that there's a profession called engineer.
Okay.
My father worked for Oil and Natural Gas Commission. Then I came to know about this entrance exam called Joint Entrance Exam. So I wrote that. And I landed up at IIT Kanpur. So that was that. And that was the first time I went to a technical institute, stayed in a hostel all on my own. And I would say that was the turning point in my life. Okay, I mean, coming from a middle class family where you are sheltered by your parents all the time. So for me, coming to IIT Kanpur was a very big deal because it exposed me to not only living alone and learning the challenges of making decisions.
Right.
I met students who were exceptionally talented, and that is one good thing about an educational institute like an IIT, where you get an opportunity to study not only with the best teachers, but also with the best students, and that's immensely broadening. So I came across people who are not just good in science and technology; they were extremely talented, let's say in sports, in music, in art and culture. So it really broadened my horizons. So I graduated in '88. From '84 to '88, I was in IIT Kanpur. And then in '88, I went to University of Minnesota.
Okay.
That's again in Aerospace Engineering Department. There I got an opportunity to work with one of the leaders in computational mechanics, Professor Typhoon Tezliwar. So I did a master's with him, a PhD with him. And that got over in somewhere in '92. Then I did a postdoc for 2 years at the University of Minnesota. And then '94, I came back to IIT Kanpur.
So, Professor, at that time and even now, if you graduate from IIT, normally go and pursue career abroad only and then don't come back. So, you are one example where you thought of coming back and going for a faculty position in IIT Kanpur. So, can you tell us something about that, sir? What was the reason?
Right. No, that's a very important point that you have made, and I think it was in my destiny to get the opportunity to speak to you and to serve my country. So I think that's the primary thing, that I was destined to be here.
Right, sir.
And then other things happened that led to that. And I strongly believe that one should not forget one's roots. The fact that I am born in India, the fact that I am born in a middle class family, uh, those are my roots. I mean, they are realities. And simply because there is some other country which looks better to me or appears better to me, or it seems they will give me better opportunities, uh, I don't know how much comfortable I'll feel by living there for the long term. So I've always felt that I belong in India. I mean, this is where I was born. This is where I was raised, and this is the country which really gave me whatever it did, whatever I could gather from it. So it is only fair that I spend major part of my life back in this country. It is not that I did not enjoy staying in the US. I mean, that was an excellent period. I mean, I had a lot of fun there, both intellectually and in terms of personal life. But the fact remains that I belong here. I mean, this is where I feel more comfortable with. If I sit in a rickshaw and I can have a chat with the rickshaw guy, I'm not sure how comfortable I would feel in talking to strangers in the US. There's always that apprehension. So I think I was destined to be here. That kind of sums it up.
That's good also. At least we retain good people and technocrats like you, sir, back home. And that is a learning for others also who graduate from IITs, and they can come back. Because I have interacted many such professors who are graduate from IITs only, though they got educated abroad, but then they came back and now serving the nation, as you rightly said, sir. Professor, my next question to you is related to your department in which you are presently serving, that is Aerospace Engineering Department. So my first query will be like how you decided to get into this department, because this is interdisciplinary department, and we can have faculty from different departments into this from the other core departments. So how you came to this aerospace department, sir, and how this aerospace department is all about of IIT Kanpur?
Okay, okay, okay.
Yeah.
So, modern day engineering, no matter which discipline you are in, is interdisciplinary by nature.
Right, sir.
And especially, as you have said, for aerospace engineering, it is heavily interdisciplinary. If you are going to design an aircraft, for example, there is not a single company which can say that they design everything about an aircraft. For example, Boeing does not make engines, right? Airbus does not make engines. So you design an engine, you design an aircraft based on the components that are available to you, and you design some of them, and the others actually you just source them from elsewhere. So it's a very strong systems engineering. Each component is extremely important. So flight systems will be important, and propulsion systems will be important. There are aspects of structural integrity, how you save the mass so that you can make a competitive machine, and so on and so forth. How you put the best high lift devices, reduce your drag penalties. Those are all extremely important. But they all go towards one single device, an aircraft. Right? Similarly for a spacecraft.
Right, sir.
So I think the aspect about aerospace engineering is that it is not just the technology which is cutting edge as far as every component is concerned. I mean, you look at the tires; they are the best you can get. They are far superior to car tires. You look at engines; they are the best engines you can get. But then, how do you match all these different components that you get into one big system, and it still functions with extremely good redundancy, with extremely high safety? So that's actually a miracle. So even today, when I see a 747 fly and take off, I still cannot believe that such a large machine can actually fly. It is really a miracle. Yeah. So I think all children are they are just inherently glamored by flight.
That's true.
So you ask any young child, what do you want to become, and they would say you want to be a pilot. Right?
That's true.
So aerospace, I think, is ingrained in almost all of us.
Right, sir.
And when I was a class 12 student, one thing that when I went for counseling after clearing my JEE, so the professor whom I was asking, my dad was also asking that which department I should opt for. So he asked me, what is your favorite subject? And when I said, math and physics, he said, okay, then you should go for aerospace. Okay. And that kind of thing has, just stayed with me. Okay. And since all my degrees are in aerospace, so when I came back, it was only natural that I joined the aerospace department.
That's great.
So I will tell you a little bit about our aerospace department at IIT Kanpur.
Right, sir.
It's one of the oldest departments in the country in aerospace. In fact, I'm very proud to tell you that there are a few facilities that only IIT Kanpur Aerospace Department has. Great. For example, we have our own flying facilities. We have a flying laboratory where we own an airstrip. We have aircrafts. We have a full-fledged maintenance department to take care of the aircrafts. And we conduct experiments in flight to educate our students about the flying abilities, the flying qualities of aircrafts, and collect parameters. For example, when you turn an aircraft or you put it in a climb, what is the stick force that the pilot would feel? What are the parameters that you study theoretically and you are able to actually get from an aircraft? So we have this facility where we can give flight experience and measurements to our students. This is really unique. I think even in the rest of Asia, there may not be too many colleges that can boast of such a facility. Then we have a very large wind tunnel facility, a national wind tunnel facility, which is again a national facility. We have facilities for rotorcrafts, okay, helicopter engineering. Then we have facilities for UAV, unmanned air vehicles. Many things which are really high technology, and it has been possible because of extremely competent colleagues who have set up these facilities. They maintain them, and they train students to do high-end research. And naturally, when you do that, then there is a big chance of doing interdisciplinary things, interact with them, learn more, and be nationally relevant.
Right, right. Professor Sanjay, you have been to United States also, so I'm sure you have seen facilities there also, and you keep visiting also these facilities. So one query in the minds of a majority of the students is how come the facilities there in United States, or for that matter other developed countries, is different from that available in IIT Kanpur, though you mentioned it is one of the best in country. So how it is different from other nations, sir, and if it is different, how we can upgrade it if it is lacking in some domain?
Sure. So, this, especially aerospace, is a very capital-intensive sector.
Yes.
I mean, everything is expensive.
Right.
And one thing that really kills us, all of us, is the US dollar to rupee rate. Anything that you buy, there's that factor of 75 that
multiplies.
Is right? It is universal, whether you buy a color TV or you buy an airplane or or a computer, anything.
Right.
That said, there are a few things which make us different than the so-called developed countries, and let me list some of them. I think the first thing that is different is the way we raise our children, the culture. In a typical Hindu family, the father or the grandfather is the leader of the family.
True.
And everybody goes by their decisions. So as long as I live with my dad, and long after I've even left the home, I'm going to consult them, and they will play an extremely important role in my decision making, to the extent that I don't make independent decisions. They're always influenced by the earlier generation, which is good and bad. I mean, it is good in a personal sense, but if you look at the national scenario, when these people are going to grow up, and you can't have dual personality, that you have a personality at home and another personality at work. So people are not able to make decisions which actually will grow them and their country. That is one thing. We tend to be very safe. In India, we always say security comes first. There should be a job security. Let's get a government job. Even if it pays less, it's okay. At least we have a security. So that kind of a decision making actually comes from our upbringing. Right? So it is, I mean, it's a fact. I'm actually very proud of it, because it is very good in some sense, but it has implications in how we conduct ourselves professionally. That is one thing. The second thing is this business of good students in class 12 coaching for competitive exams. It actually kills their hands-on skills.
Right.
So if you look at the experimental skills of our 12th class students, 11th class students, we discourage them. क्या करोगे भाई, experiments करके जाओ, पढ़ो, coaching करो,
JEE की तैयारी करो,
JEE की तैयारी करो. Now till that point it is okay, because ultimately they are studying, and studying is good. So I think there is some merit to it. But what that does is that people in their careers who end up pursuing getting their hands dirty, setting up experimental facilities, laboratories,
right, sir,
we just don't have it. Because it is kind of looked down upon. This guy got good marks in practicals, but in theory he got very little marks, so he must be a duffer. Everybody is good at experiments. So that culture, I think, unless there is a shift, we will continue to have this problem, right? So coming to the 3 points that I made, one is the cost, the second is the decision making, and the third is basically some reluctance to go into hardware and make big decisions to set up big facilities, which actually may fail. Any project that you undertake, it just may not work. Yes. Right? I mean, there's a risk. So how do you manage your decisions? How do you take them through? How do you take a few blows on your chin and still keep up the tempo? I think that is something we need to learn as a nation. The newer generation is good. I think when I look at my son, when I look at his friends, I think they are more enterprising, and I'm very pleased to see that.
Right.
Now, why are our facilities not so good compared to the ones outside? A, we don't develop our facilities ourselves, right?
Okay.
So today, suppose I want to set up a flight simulator.
Okay.
And I say the easiest thing is, let me go to Airbus and ask them, can they set up a flight simulator at IIT Kanpur? So they will charge me a whole lot of money. They will come set it up. We'll train a few people. But then 5 years later, 10 years later, we are back to square one. It's obsolete, right?
It's true.
On the other hand, if we had designed it ourselves, we had put it ourselves, then we would be many, many steps ahead. We would be competing with them, right? So the problem is that you can never, we are always playing the catch-up game, that they are better than us, let's catch up with them. You look at some other countries, you know, like China, they have invested very heavily in setting up their own facilities. In our country, for a variety of reasons, we tend to not duplicate facilities. So we will be very reluctant and saying, by IIT Kanpur mein there is a flight lab, so there should be no other flight lab. You set up an engine test bench in IIT Bombay. You set up a structural facility in IIT Madras. Why can't we have duplication of facilities so that, you know, there is more redundancy, people get trained, they work forward. So unless we make a conscious decision that we need these facilities and our laboratories should be self-sustained and we must develop them, not just upgrade them. See, the word that you will always hear in our psyche is, we must upgrade our labs. You know, why should we upgrade them after long periods of time? It should be a continuous process. There's nothing called periodic upgrading. Why should it be upgraded after 5 years? I think it should be upgraded as the experiments become better, and we should do it ourselves, right? So I think in the end, it is some financial aspect and then the culture. We must take pride, and people who do this should be recognized. I mean, they should not be just looked as technicians or some lower people. They should be given proper respect, and then that cadre of people will come up.
That's true. So, Professor Sanjay, our aerospace industries, especially in the private sector, we think of Hindustan Aeronautical Limited kind of organization, but when we talk about private sector, then we do not find much examples of aerospace industries. And though it is a highly demanded, we still import, we purchase from Boeing, Airbus kind of industries only. So, what do you see the reason behind this? Is this same related to this what you just now answered?
Right. So you know, I think that's a very important point. I mean, so let's put things in perspective. Can India do it? Can we make our own products? I think we have sufficient examples that we can. You know, I'm very proud to say that the light combat aircraft, the Tejas, which DRDO, specifically ADA, with help from HAL, you know, it is known to be a world-class aircraft. It is the lightest, one of the lightest aircrafts in the world in its own class of aircraft, and people think it's you know, right up there. It's a very good aircraft. Our Dhruv, the ALH, you know, it's again it's a very good machine.
Yes.
So the point is, we can do it. There is no problem. Then there is a problem. I think the problem comes in, these days you cannot say I will only sell in India. Okay. So you cannot have a culture where you say I make the aircraft and you force Indian Airlines to buy them, or Air India to buy them, or Indian Air Force to buy them. I mean, you can gently cajole them and say that, you know, please help us. But you know, they are going to buy the best aircrafts.
Yes.
And best aircraft means you now have to compete globally.
Yes, competitive.
So what happens? If I make a product today that is globally right up there, it is competing. You cannot simply make an aircraft and say, okay, buy it and fly it. There's a big program in actually certifying aircrafts. So it's just like drugs. You make a drug and there is a very long period in which the drug has to be certified that it is safe. Same thing with aircraft. even after you design an aircraft, you fabricate it, you manufacture it, it still has to be certified that it is good to go. It's a very intensive program. So it is possible that if you don't think of that right in the beginning, even though you have made an aircraft, by the time you have certified it and you're ready to go, somebody else has already done it before you. And maybe you are not as contemporary as you should have been. So there are very small things that we need to keep in mind when we make these devices, but I think we can do it. I think the key thing is the vision. Today, my understanding is that when you look at our national programs, they are very good programs, very competitive programs, but they are released in piecemeal. So somebody will say, you do phase 1, and then we'll think about phase 2. Then you do phase 2, then we will think about phase 3. So what happens? You spend all your energy in phase 1, and then there is a time lag between phase 1 and phase 2. And you cannot plan the whole thing because the entire funding is not available to you. You cannot get the right manpower because you have only been promised funds for phase 1, whereas you are thinking about phase 5 when you will scale up and add manufacturing. You need to get those people ready now. You cannot say that manufacturing will start after my entire design is complete. Where are the people? Where are the facilities? So I think that vision and the will to actually see through a project, and it will be very expensive, and there is definitely a gamble in that. I mean, it's possible it may bomb, it may not work, but that can be managed. So if you do a implementation that at least you get this product, if not the best product that you want, it can be handled. And I think there is some thought in that. I am quite hopeful that things are looking up, and India is talking about regional transport aircrafts. So NAL, for example, in Bangalore is talking about Saras. It's a small aircraft. Then there are some projects about these regional connectivity aircraft. Right. So India is looking at some programs, and I think things are looking up. So we might see some exciting programs very soon
coming up. Okay, Professor, my next question is related to the comparison of aerospace engineering as a academic subject in India and US. Though you have already mentioned the practical learning aspect of this, but any other difference which you can mention here?
Sure. So I think it is very intimately related to the kind of industry we have.
Yes.
Okay? So as I said, it is very capital intensive. So a private industry coming up with that kind of an investment and saying, we'll make an aircraft is a little bit, a little bit far right now. I think the government has to support. And as soon as the government comes in, then, you have a limit on the emoluments that you can get. Right. So, and that's a catch-22. Government cannot say that aircraft engineers will get paid more than railway engineers. I mean, that how can the government say that? I think it is very logical that there has to be some kind of a unification. But good aircraft engineers are difficult to find. So a big problem that occurs in our country today is retaining good manpower. And along with that, people move to other sectors. So if I was a student who is graduating, let's say in the US, right, I would get extremely well paid in aerospace industry. But if I am today a student who's just graduated, let's say I have a doctorate in aerospace, the hiring process, it's a little bit long because again there are government procedures and they have to be there. I mean, that's how they are. You and I cannot change them. So even though the managers would like to find shortcuts, but because of these elaborate procedures, they cannot hire people so quickly. So then naturally people start looking for alternate employment. So even though I have specialized in aerospace, maybe the banking industry will pay more, so I go there, right? So two things are very different. A, we don't produce that many numbers, like in the developed countries. If you look at the number of PhDs that we produce in aerospace, they are actually minuscule. The quality PhDs that we produce every year. Whereas if you look at countries like China, US, I mean, they produce by, you know, by hundreds. We may be producing maybe a dozen a year. So there's a very big difference. So the numbers are not there. And then the employment opportunities. So these two coupled with each other, I think it kind of puts up a very strange situation for employment in aerospace, because the private sector, if you look at it, you know, you have Airbus today in India, you have Boeing in India. So all multinationals have made their houses. But typically they don't pay so well in the first few years, because they will hire you as trainees, then they will check you out, what your loyalty to them is, are you going to be retained? They will not give you extremely secretive projects to begin with. So the work may not be very exciting. Some may find it exciting, some may not. So all these things put together, so unless we have an indigenous industry, which is just thriving and pumping in money, there will be some difference between what let's say the US has to offer or Europe has to offer versus what we have in India. I don't know if I've addressed your question.
That's true. You have answered largely my question, my query, sir. And my next point was related to your domain of research, professor, in aerospace engineering.
Sure. So, Dr. Singh, I would like to put myself as not just an aerospace engineer, but somebody who is very curious about how things work. They sometimes are related to aerospace, sometimes they are not directly related to aerospace, right? So let me give you some examples. So I would, for example, be very interested in looking at how airplanes fly. So how lift is generated, right? What are the high lift devices? So when you travel in an aircraft, you take a window seat. Sometimes, you know, you will see during takeoff, some leading edge slats or trailing edge flaps, the wing will get extended, right? So how do these work, for example? So when you go to very high speeds, what happens to the interaction between the boundary layers and, let's say, the shocks? Okay, so those kind of problems. So these are typically aerospace problems. Or, for example, aeroelasticity. So I have a wing, but then I also have, because of flow, some forces on it, and the wing may start vibrating. Okay, maybe at a low frequency. So how does this vibration affect the structure? And how does these vibrations affect the flow? So there's a field called aeroelasticity, for example, right? So looking at those problems. How do I generate an optimal wing so that it gives me large lift, little bit less drag, and so on? So shape optimization. Then I also have interest in other areas. For example, vortex-induced vibrations, which may not necessarily be aerospace, but this is general fluid mechanics. Or, for example, turbulence.
Right.
How do flows become turbulent?
Yeah.
How does a boundary layer transition from a laminar state to a turbulent state? Fluid structure interaction. So one of my students, for example, right now, a senior PhD student, he is looking at some problems of balloons. So when you inflate a balloon and it suddenly fails, suppose I prick it, then, you know, how does it fail? Does it fail everywhere, or is there a jet that comes out of it? How do these shocks in the membranes, how do they propagate? You know, so very curiosity driven research. Some of my students work in sports aerodynamics. So there's some work that we did on cricket balls. We are still doing that. So in fact, I wrote an article a couple of years ago on Bumrah. How does Bumrah generate his variations? Why does his ball dip so much? What is the physics behind it? You know, on badminton shuttlecocks, for example, what is the difference between a synthetic shuttlecock and a duck feather shuttlecock? So we work in many kinds of areas, but the theme is fluid mechanics and its interaction with structural mechanics.
Okay.
So so the students or the viewers can visit my webpage, and we have put in some sample things there. And if they are interested, they are most welcome to contact me, and I'll be happy to interact with them.
Great. Professor, so many students must have graduated under your guidance and all. So I want to ask you, sir, what are the various entrepreneurial opportunities related to the domain of learning, research domains of your interest, and otherwise also in general about this department.
Okay, great. So, so once you have so let's first talk about the bachelor student, the BTech students.
Yes.
Right? And then we will go to MTech and PhD because they are more specialized.
Yes.
So if you really look at a BTech curriculum, okay, it's typically a 4-year program, and out of that, maybe only about 25% is actually the core courses in the department, 25 to 30%. Rest are all general courses, which any other engineer would do. So out of the 4 years, typically about a year or a year and a half is what is special to aerospace engineering. Otherwise, all engineers are same. So if you look at the difference between a chemical engineer and an aerospace engineer, it's actually about a year and a half. So I could be an aerospace engineer, and if I want to do electrical engineering, in 1 year I could become an electrical engineer, right? So this is how our students are actually raised in this institute. So they are very confident that they have been shown how to learn. So content is one aspect, but how to have confidence that you can learn any content that is thrown at you is also something that that they go through.
Yeah.
So naturally, with that background, they are very curious and they take up all kinds of things. So jobs that require consulting, for example, it could be business consulting, it could be technical consulting. Jobs that are hardcore aerospace. So first, let's talk about aerospace jobs. So they get hired by DRDO, the defense labs, and placed in one of their national labs somewhere. Some of them get hired by HAL. Then CSIR comes to the campus sometimes. Sometimes they have tests and they hire our students. So these students could get hired by NAL, for example, National Aerospace Lab. Then there are other private companies that I talked about. For example, Boeing comes to our campus for hiring. Then you have Airbus that comes. Typically, all engine manufacturers, GE, Pratt and Whitney, they all have installations now in Bangalore. So they would sometimes hire our students. So aerospace is quite. There are a lot of opportunities. Okay. Then of course many of our students they would tend to do higher studies, maybe do masters or PhD.
Yes.
And then take up research jobs.
Yes.
So research jobs would include faculty positions, or maybe for example a leading scientist position at GE, or some of them will get hired by the DRDO labs and so on and so forth. So many of my students, for example, are faculty members in other universities, in other IITs, in other institutes. There are other students, for example, who would say, well, we want to do technical work. We don't want to do banking or software jobs, but it would be technical, let's say in the area of fluid mechanics or structural engineering. Okay. So they would join these companies, for example, CFD companies, or they would join structural mechanics companies, like ANSYS would offer them jobs, or there are many other companies that would offer them jobs. So they will pursue the so-called technical job, but not necessarily aerospace.
Okay.
So you will see a lot of people branching out and doing all kinds of things.
That's true. Professor, like at the level of graduation, students, as you rightly said, they are trained in multiple dimensions or multiple aspects. So they find themselves comfortable in any kind of job, starting from banking to core domain. So for them, getting into job is not a problem. On the other hand, for students who get specialized, that is a good thing also, and sometimes that becomes handicap because they need to get into that specialized domain only. Sure. Now, many students, when they tend to choose the department, like when I want to go for higher education, should I go for aerospace or should I go for some another department? So placement is something which is very much in their mind. So I wanted to ask you also, sir, related to this only, that a student who is aspiring to get specialized in aerospace through the courses like masters and PhDs and all, how difficult or easy or challenging or opportunity they have to get into the jobs once they graduate properly?
Sure. So if I talk about the job profile, let's say in our institute, the trends that I have seen more or less over the last few years is
Right.
that the dual degree students who have a BTech MTech program, which is a 5-year program, they are the most sought after commodities. So
Okay.
companies really prefer them
Okay.
because they have a basic degree in aerospace and they also have some specialization.
Specialized also.
And also, their thinking process is different because they have learned during their thesis how to work independently and how to formulate a problem, solve it, and if they get stuck, then how to find their way through, right? So that art they have picked up during their program. So they are the most sought after.
Yeah.
Then come our BTech program because they truly have a IIT stamp. So obviously the companies have a preference for them, and I mean they are good as well. The next set of students to be picked up are the MTech students. Okay, MTech students are a little bit more specialized compared to BTech students. So companies would typically ask them questions about the thesis that they have done, the courses that they have done, and they also look at some of the background that they have in their bachelor's program, and then they make offers. But by and large, I think students are able to find jobs. Okay, my one point that I tell my students is the following: that let's say there are two disciplines, discipline A and discipline B. A has a very hot market and B is lukewarm, not so hot. I, as an individual, can only do one job at a time. So even if I go to a very hot market and somebody makes me 20 offers, at the end I can take up only one offer. But if I'm in a lukewarm field, which is not doing so well today, I only need one job. I don't need 20 jobs, right? The point is that if I am good, if I am willing to work well, if I am sincere, I will get that job. So what I have seen from experience is that students who are sincere, who do well, job is not a problem.
Certainly, that is certainly true. Because IIT Kanpur itself is a very big brand and certainly companies come. So if students are well prepared, as you rightly said, getting job should not be and is not a problem, Professor. That is true. So my next, I want to discuss with you related to the projects being handled by you as of now.
Sure. So I will not be able to talk about some of the projects, but I will give you some idea. Okay. Some of them are actually confidential projects of national interest.
Okay.
So at IIT Kanpur, all faculty members are expected to do roughly three things. One is to teach. We are the flag bearers of passing on the baton to the next generation. So we must teach them well. So these are some courses. These could be electives. These could be core courses. Then we are supposed to guide students, mentor them. And these could be in the form of BTech projects, master's thesis, PhD thesis. And then the third thing is to participate in national projects. Okay, because that is important also for nation building. And it also brings freshness to the curriculum. If I don't interact with the industry, then how would I convey to my students what is contemporary and what is important?
True.
So what the question that you have asked relates to the third aspect of my professional life, which is indulging in some projects.
Right.
So typically there would be projects where they are routine projects, like some testing. So I do both experiments and computational work. So I do CFD and wind tunnel testing. So sometimes there'll be a client who will say, we have to test, let's say, flow past a certain object, maybe a motorcycle or a car. So I can give you some very interesting examples. So there's a car manufacturer who wants to find out what is the percentage increase in drag if I extend my side view mirrors. Okay. Or for that matter, how does the posture of the driver change the drag of a motorcycle, the fuel efficiency? Or if I'm wearing a white shirt, why does it get dirty on brand A of motorcycle but not on brand B? Because it is related to the flow structure and the dirt will circulate, right? So these are very, very interesting projects. So these I would put in a category where they are not so involved in science, but there is some novelty to them, and there is so that is one aspect, the fun kind of projects where you see an immediate answer, right? Then there would be some projects which are really very challenging. Okay, for example, I may have to estimate some characteristics of an aircraft. Okay, and I may have to do some wind tunnel tests or maybe some modeling of that, or for example about an engine, or maybe of some bridge that is coming up, and how does the vortex shedding or the airflow on the bridge affect the natural frequency and the vortex shedding of that bridge and its vibrations. Okay, or for example the design of let's say the deck of a ship. How does the breeze affect the temperature and the signals that some machine would receive on a cruise ship? Okay, flows on chimneys, buildings, maybe design of wings for an aircraft. So there are a whole set of projects that we do. Unfortunately, being in the aerospace sector, it would not be wise for me to talk too much about them in open. Okay, but as far as our students are concerned, they actually have to write a thesis which is an open thesis. It is not in the confidential domain. I mean, it goes out for review and it's in public domain. They need to have publications.
Right.
So no matter what project we take, what work we do, we always find an aspect of it which is scientific, and if a student is working on it, they would definitely be able to address that and put it in their thesis.
Great.
So I can give you one example. There's one student who is working on a project. He wants to see can you design aircrafts with rectangular wings, but they don't need tails. So can you come up with tailless aircrafts?
Okay.
We do not have so normal aircrafts, tailless aircraft would have a swept back wing. Okay. So he's saying, can I have a rectangular wing, but a tail is not needed? Can I design an aircraft like that? Okay. So this is a very challenging and very interesting problem, and it is of importance to certain projects also. But this guy is doing it for his thesis.
That's good. Professor, when we look forward for students in higher education domains, like you said, MTech courses there, PhD courses there, students sometimes get confused between MS course also. I'm not very sure whether that course is there in Aerospace Department of IIT Kanpur, but students do not have clear idea or demarcation between MTech course and MS course. So what is the difference between these two?
Actually, to be honest with you, nobody knows the difference.
Okay. Other than timings, I think it is a long duration program.
I can throw some light on it. It may not be very politically correct, but I will try to give you my perception of it with no strings attached. It is purely my perception. Okay. See, there are 3 degrees that a typical institute will offer: a bachelor's degree, a master's degree, and a PhD degree, a doctoral degree, right? Now, a master's degree could be of many kinds. It could be a MTech, or it could be a MS, right? But there are only so many seats that one can have, okay, because of the availability of faculty, because of the availability of facilities. And typically in our country, MTech has been driven by MHRD scholarship. So any student who clears GATE and registers for an MTech typically would get a scholarship. It's in the form of an assistantship where they would work as a teaching assistant or a research assistant. So essentially, whatever money they get as a stipend, they have to do some commensurate work for the institute or the department to kind of make up for it. Okay, so that's the scheme of the government. Now, what has happened? There are a set of students who don't really qualify for the entrance of an MTech program for a variety of reasons, right? Because their background is not proper, or so they are not able to get a GATE score that could give them an entrance to a MTech program. But they have a fire in their belly and they want to do well. So how do you bridge this gap, that there are these students who apparently have not done so well in evaluations, but they are extremely excited to do well. So the MS program is a longish program, which would primarily be for students who are not able to get through an MTech program. It's a little bit longer, so they will do a slightly more coursework spread over a longer period of time. And hopefully they can also use this to do more research than a master's student, an MTech student.
Yes.
MTech program is typically 2 years.
2 years program.
So you get about a year and a few months to do your thesis.
Yeah.
Whereas an MS by research is 3 years typically. And the student can spend about 2 years on the research problem. Okay. So the advisor is extremely happy. He is able to give a project which the student can work on for a slightly longer time, right?
Maybe it is also some mini PhD, professor. Sometimes it is called MS.
Right. Unfortunately, yes. So I think we should be very open. I mean, if a student is getting a master's degree, then the student should be treated like a master's student. I mean, why should you want to treat him like a PhD student? True. Then, enroll him in the PhD program and give him a PhD degree. So many universities do that. They take students in the MS by research, and then after a while they would convert their programs to PhD programs, right? Okay. But what I have seen from experience is that if I am a student and I have a choice between an MTech and an MS by research, then I would typically take the MTech program. Okay. That's usually a better choice for the students. A, it is shorter. B, you still have the same options. Nobody stops you from converting your MTech program to a PhD program. Nobody stops you from doing a PhD after MTech. So why would you spend 3 years in a master's program if you could get it in 2 years? But those are my views. Maybe I'm in a minority. But it is fair that I give my views.
That's good. In fact, this interaction is all about taking your views only, sir. And I'm happy that the way you have presented it, it's really good. Professor, my next question to you was like, whenever some student aspires to go for higher education in premium institute like IIT Kanpur, and he's aspiring to go for MTech or MS research or PhD program, then how important is learning of computational fluid dynamics or CFD, as you mentioned in your research areas also, how important it is for him to have knowledge of this? Though in many of the graduation courses all over India, this is not the part of their regular curriculum, it is elective or something. So how important it is for him to learn this? And what do you see in a typical student when he comes to IIT Kanpur for higher education?
Sure. So, this kind of relates to what I said earlier, that I think the way a person learns how to learn is more important than the content itself.
That's true.
So I went in '84 to an engineering college and I became an engineer in 4 years. Right? 4 years from 12th class passed, I became an engineer. If I had gone to a medical college and if I had done well, then in 5 years I could have become a doctor, a medical doctor. Now today I am, in my 50s and I say, "Nahi bhai Sanjay, ab tum doctor karo, ab MBBS seekh hi lo." So the question I want to ask myself is, as of today, if I want to become a doctor, how long should it take me? Should it take me 5 years, more than 5 years, or less than 5 years? And my intuition tells me that with my knowledge and my experience, I should be now taking less than 5 years. Okay? Because I already have some background. So now coming back to the question you asked, there's a person who did not know CFD and he wants to come and, let's say, work with a research group and do CFD. A CFD course would have taken him or her 6 months or 4 months in their college. But the student is very good, willing to learn, sharp, clever. At the most, it should take him or her 4 months.
Yes.
Maybe even less.
Yes.
So to me, it appears content is not so important. As long as I see a student, if he or she has done well in the class. So the student was exposed to a course in math and he or she did well in math. they were exposed to a course in, let's say, design of gears, or maybe solid mechanics. They did well. There is no reason for me to believe this student will not do well in CFD, right? So for me, when I take students, I look at their interest. Are they really interested in working in CFD, or they are just throwing buzzwords, right? But if they are good, they are willing to learn, and they have interest, their prior background, it doesn't matter to me. They can learn. So in a nutshell, I believe that the performance of a student in whatever they have done so far is far more important than a specialization that they may have acquired but not done so well in that.
Okay.
See, the ideal thing would have been for me to get a student who is wonderful and is also wonderful in CFD if I am doing CFD, or wonderful in experiments and does experiments. But if I get a wonderful student who has no exposure to CFD, no exposure to experiments, I'm okay with that. That's good.
You can take that. You can take that.
Absolutely.
Okay. Professor, NPTEL is a good source of information, especially for those students who are not that lucky to graduate from premium institute like IITs. So what is your take on NPTEL, and can you please tell us if some student wants to learn more about aerospace domain, then is there sufficient content on NPTEL?
Okay, good. In fact, it so happens that because of this pandemic, we all have now more information about online online learning. So I have never participated in the NPTEL program. Never taught a course, although I was approached, but I felt at that time I was busy with other things and I may not be able to do justice to a course. But this semester I am teaching an online course on fluid mechanics.
Good.
There are about 350 students in my class.
Good.
And they are all out of campus, obviously.
Okay.
So the mechanism is that we record our lectures, put them, then they view them. So it is just like an NPTEL course.
Okay.
Right. So you have to record, you put them, then you give them assignments, you evaluate them, and that's how the learning goes. And it's worked out great. I mean, we have to, both the students and I, we have to get over a few inconveniences that we are not so used to. But I think it has worked out fine. So to answer your question, I think NPTEL is a great resource. If people can lay their hands on lectures. In fact, these days, it's not just NPTEL. I mean, there are lectures from MIT, Stanford.
Yes.
So it is the world has become very global.
Yes.
You don't have to just learn from a teacher at IIT Kanpur. I mean, you could learn from a teacher in Stanford or whatever, wherever. And so that's a great resource. In fact, I myself, when I want to learn something, I use online resources and listen to lectures and learn, and that's great. So I strongly encourage that.
Sir, your lectures are available on NPTEL or on some another domain?
So I put my lectures on there's this platform called MOOCit, but it had some problems. So I ended up putting them on YouTube. So all my lectures are now on YouTube. So if you just put my name as Sanjay Mittal, IIT Cake and Fluid Mechanics,
great.
You will see my lectures and you can send me hate mails.
That's great because students keep finding really good content, and YouTube nowadays has become big source of information, no doubt. But finding and looking into that is something which is important. So certainly,
in fact, what I have done is on my homepage, I have a web page. And it's an IITK web page, and on that I have put a full page about the content of the lectures and the URL. So students can actually
go to that web page, and from there they can land up in YouTube.
They can land up in YouTube.
Great.
If they view them, I'll be very happy for the feedback. I mean, I can.
No, certainly, sir. In fact, I would try to put the link also somewhere here only, so that they can directly access that particular thing. It will be great for them to go to the web page also. So, Professor Sanjay, we have come to an end of this entire wonderful session, sir. and I'm really thankful to you for giving the information in such a lucid way and such a free flow way. And I have got answers to all of my queries, and I'm very sure, sir, it is going to help the students, thousands of students over there.
It was a pleasure for me. Thank you very much for this opportunity. And you know, you are so charming. You have your way of putting things and you know, allowing the other person to put their views. So it was an absolute pleasure for me. Thank you very much.
That's a big compliment to me, sir. Thanks a lot. Thank you, sir.